Alright, hey guys, we're back for lesson 5. This time we're going to look at chemical reactions that involve some kind of gas. So I've just called these kind of fizzy reactions. And a really classic fizzy reaction is this, sherbet. You've probably seen it before. It's actually when you mix the two substances together, inside there's some bicarbonate of soda and some citric acid, which are both solid acids and a solid base. And when you lick it, it causes a chemical reaction which makes the sort of like bubbling and fizzing of the carbon dioxide, and that's what kind of makes your tongue go all funny when you eat sherbet. Now, I use a bit of a new word there. You might have heard me use it before, and that word is base. A base is very, very similar to an alkali. A base is anything that reacts with an acid. So, alkalis are bases. But however, alkalis are a smaller subsection of what a base is. So, all alkalis are bases, but not all bases are alkalis. For something to be an alkali, it has to dissolve in water and have an OH group in it. So sodium hydroxide has that OH group because its formula is NaOH. Calcium hydroxide has an OH group because its formula is KOH. Now, whenever we have a metal reacting with an acid, what it will do is it will create bubbles of gas. And the gas that it makes is hydrogen. And the general formula for this is a metal plus an acid makes a salt plus hydrogen gas. Now, this is quite easy to remember. You just have to remember the term MASH. Metal, acid, salt, hydrogen. So, if we react zinc with hydrochloric acid, what will we make? Well, if you remember from last lesson, when we do a neutralization reaction, we have to change the name of the acid. So it goes from hydrochloric acid to chloride. And the zinc remains unchanged when it becomes a salt. So, it's zinc plus hydrochloric acid makes zinc chloride plus hydrogen. You can see here that I've highlighted the terms where they appear on the reactants, and here I've done it for the terms in the products. So you can see that the zinc in the metal became the zinc in zinc chloride, and that hydrochloric acid changed its name to chloride. So it goes from hydrochloric to chloride. So zinc plus hydrochloric acid makes zinc chloride and hydrogen. Note that in this reaction, no water is made, which is different to what we learned when we did our other neutralization reaction back in lesson 4. When you do this kind of chemical reaction, you can see something that happens like this. Here's a metal, it's magnesium, in some hydrochloric acid, and you can see bubbles of hydrogen gas appear on the surface of that coil of magnesium. Eventually it will look like the metal dissolves, it disappears completely. But that isn't actually what's happening. The metal is reacting with the acid and becoming a different substance. That new substance is what dissolves. So the salt that you make in the chemical reaction dissolves. So it makes it look like the metal is disappearing. Alright, another example is when an acid reacts with a carbonate. So if I have an acid reacting with a carbonate, the general equation is carbonate plus acid makes salt, water, and carbon dioxide. A little bit more complicated for this one. So if I do a reaction, I'm going to react copper carbonate with sulfuric acid. What I'll get is copper carbonate and sulfuric acid. Now look, remember I'm taking the metal of the base and we're changing the name of the acid. So in this case it's sulfuric acid, so remember that changes to sulfate. If you don't remember all this, go back and look at lesson 4 again. So what we're making is copper sulfate, making water, and we're making a third product, carbon dioxide. You can see I've highlighted with the copper and the sulfuric acid here, where we change our names, and that copper becomes the copper in copper sulfate, and the sulfuric in sulfuric acid becomes the sulfate of copper sulfate. Everything else will always be the same in a reaction like this, providing that you're reacting with a carbonate. Now when we do this reaction, you can see some calcium carbonate here in this picture reacting. You can see the bubbles of carbon dioxide that are coming off that carbonate right there. Again, it will look like the carbonate dissolves in this case, but actually all it's doing is reacting, and it will turn into a salt, and that salt is what dissolves. So it will look like that it dissolves, but it doesn't really. It's not really what's happening. Now, by doing some tests, when we collect these gases, we can work out what they are. So if I do the metal reaction and try and capture some hydrogen, I can test for that. And what I would do is I'd get a lit splint, so I'd literally set the splint on fire and put it into the tube of hydrogen gas. And you can see this in the Fizzy reactions experiment that I've done for you guys. If it doesn't make a squeaky pop, then it's definitely not hydrogen, so it might be carbon dioxide. What we should do then is add some lime water and shake it with the lime water, or bubble it through the lime water. If your substance goes cloudy, then we know that whatever you added to the lime water is carbon dioxide. So by shaking the carbon dioxide with lime water, you end up getting the lime water going from clear to cloudy or milky, and that's the test for carbon dioxide. Alright, thank you very much guys. Have a good day.